In this video, I will cover synchronizers in Java. Synchronizers are utility classes for coordinating access and control in multi-threaded applications. Let's start from the log. Log interface is used to access thread synchronization mechanism similar to synchronized blocks. A new locking mechanism is more flexible and provides more options than a synchronized block. So here listed the methods of the synchronizer, methods of the lock interface. Also, we have the difference between a lock and the synchronized blocks are here. So a synchronized block makes no guarantee about sequence in which threads waiting to entering it and are granted access. You cannot pass any parameters to the entry of a synchronized block, thus having a timeout trying to get access to a synchronized block is not possible. The synchronized block must be fully contained within a single method or single scope of the code, but a lock can have its call to lock and unlock in separate methods. So let's see. So lock has several implementations. It's like re-entrant lock, read-write lock, and stamped lock. Let's see some examples of the working with locks. So in this case, three threads starting simultaneously, but this run method is locked with using the lock unlock methods of the lock. Let's start it and then we can see that how it works. So in this case, thread A does until the end, and then thread B waits for the result. Then thread B, so it's like we can just synchronize this block of the code simply. Okay, let's continue with semaphores. A semaphore is a thread synchronization construct for controlling thread access to a common resource. It's often implemented as a protected variable whose value is incremented by an acquire operation and decremented by a release operation. The acquire operation either returns control to the invoking thread, immediately calls it that thread to block when the semaphore's current value reaches a certain limit. The release operation decreases the current value, which causes a blocked thread to resume. Semaphores whose current values can be incremented past 1 are known as counting semaphores, whereas semaphores whose current values can be only 0 or 1 are known as binary semaphores or mutexes. So mutexes are used samely as logs we see before because so in this case acquire method and release method are alternatives to the unlock and lock methods of the lock interface. So semaphore has many methods listed here. Okay, let's see some examples of using semaphores. So in this case, semaphores can be just like here. We have 5 permits in semaphore, and we have 50 threads in our execute service. And we have 10 threads, so we can just execute 10 threads and then 5 of them work simultaneously. 10 of them can work simultaneously, but if we see, if we run it, so in this case, 5 of them run simultaneously, and after the, for example, after the part of the threads released, the 7th and Its threads allowed the inside grocery store. So in this case, when semaphore, so after the some of them released, semaphore is just increased to the one, and then uh, is available, so become available to the seventh customer and eighth customer. Okay, let's continue. So also we have the example for the mutexes. So in this case we have semaphore with one permit and it works as the logs as I said. Here we have the release method called. Here we have acquire method called. So in this case, these operations are synchronized in one thread. So these operations cannot be performed by the several threads simultaneously because it will cause some race condition in the result. Okay, we can just run it. Let's run. So in this case, this thread 1 acquired the permit only after the thread 2 released the permit. Okay, the next synchronizer is countdown latch. Countdown latch is a Java concurrency. In Java concurrency is a type of synchronizer which allows one thread to wait for one or more threads before it starts. So in this case, you can implement the same functionality using wait and notify mechanism, but it requires a lot of code and getting it right in first attempt is tricky. With countdown latch, it can be done in just few lines. So countdown latch is the same as synchronizers. Is a thread synchronization construct. So it has the value count and then the main thread will wait until this value is decreased till the 0. So in synchronizers we can increase something this value to value and in countdown latch we cannot increase this value. So we can only wait for decreasing it until 0. So let's see some examples. In this case, we have worker threads and we have the main threads await for these worker threads. In worker threads, we give a latch to the constructor and then we will just after doing anything we want to count down this thread. So let's see what happens in this method. So only after finishing the workers main has been finished here. Okay, let's continue with cyclic barrier. Cyclic barrier class is a barrier that all threads must wait at until all threads reach it before any of the threads can continue. A cyclic barrier is a thread synchronization construct that lets a set of threads wait for each other to reach a common barrier point. The barrier is called cyclic because it can be reused after the waiting threads are released. Cyclic barrier declares an int-await method that typically causes the calling thread to wait unless the thread is the final thread. If so, and if a non-null runnable was passed to barrier action, the final thread executes the runnable before the other threads continue. Await throws interrupted exception when the thread that invoked this method is interrupted while waiting. This method throws a broken barrier exception when another thread was interrupted while the invoked thread was waiting, the barrier was broken, then a wait was called, or the barrier action will present failed because an exception was thrown from the runnable's run method. So let's see some examples here. It's about cyclic barrier. So we have tasks, so it's runnable when uh, uh, when some way we can just wait barrier and then we can just continue working. So let's see what happens with barriers main classes. So in this case, all of them printed, and then only then the all var uh, we can just see that all previous tasks are completed. So in this case, and then we will continue, all threads continue working in a random order. So it prints in a random order, so it works simultaneously. So we have several. It's the countdown latch and the cyclic barrier are same in many cases, but we have some differences. Main threads follow the threads to complete the execution. Each worker thread waits for each other to complete the executions. So in this case, first case on countdown latch, main thread only main thread waits in cyclic barrier. All threads waits to the completing. We cannot so countdown latch. We cannot reuse. So when this instance is reaches zero, but cyclic barrier can be reused by resetting barrier once is broken. No such action can be provided. So we cannot provide barrier action here, and here we can provide barrier action that is run once per barrier point after the last thread in the party arrives, but before any threads are released. Okay, then let's continue. So with exchanger. An exchanger, also known as when this was, is a thread synchronization construct that lets a pair of threads exchange data items. An exchanger is similar to a cyclic barrier whose count is set to 2 but also supports exchange of data when both threads reach the barrier. The Java util concurrent exchanger class implements an exchanger. This class provides an exchanger construct for initializing an exchanger that describes an exchange point and a pair of exchange methods for performing an exchange. For example, vx throws interrupted exception waits for another thread to arrive at the exchange point unless the current thread is interrupted, and then it transfers the given object to it, receiving its object in return. So let's see what happens here with example. So in this case, we have one example. So we have exchanger, and we can just, in this case, we can exchange this object using exchange method here, and let's start this application so to see what happening. So before first runnable has A object, for second runnable has B object. So let's print this object. So previous object thread null has A and it's exchanged with B here, this object, and thread 1 has B and exchanged with A. Here the second example. So with this we can just use put thread and then get thread, so we can just uh, implement the messaging between the two threads with exchangers. Okay, let's continue with fathers. Fathers is a thread synchronization construct that's similar to a cyclic barrier in that it lets a group of threads wait on a barrier and then proceed after the last thread arrives. It also offers the equivalent of a barrier action, however, a father is more flexible. Unlike a cyclic barrier, which coordinates a fixed number of threads, a fuzzer can coordinate a variable number of threads which can register at any time. To implement its capability, a fuzzer takes advantage of fuzz and fuzzer members. A phasor is the phasor's current state, and this state is identified by an integer-based phase number. When the last of the registered threads arrived at the phasor barrier, a phasor advances to the next phase and increments its phase number by 1. So we have one constructor and three methods here. So register adds a new unarrived thread to the phasor and returns the phase number to which the arrival applies, records arrive and await attendance, and arrive and deregister. So let's see the example of the phasor. We have my thread with phasor. So in this case, okay, let's run it and then see what happens. Phase, so in this case, phase 0 completed. So with okay, let's see. So phasor, and then we will give this phasor to the thread, and then we can see what is going on. We can just wait for the phasor. So okay, so threads will just say about notify about it, and then it will await for the advance. So in this case, await for advance is waits for all threads to just finish phasor. To just to reach this point in any cases. In any cases. So thread A, thread B, thread C started. So we can see that we can just it's like the barrier, cyclic barrier, but we can just extend the number of the threads. Also, we have condition interface, provides a thread ability to suspend its execution until the given condition is true. A condition object is necessarily bound to a lock and to be obtained using the new condition method. Now let's see the example of the condition method. So in this case, we have item Q works with producer and consumers. So in this case, with its conditions is empty is full. Conditions is empty and is full, so we can just lock unlock with using the signals, and then this is a blocking queue interface with condition instances with condition classes. So in this case, we wait here. Logs here and signals here. Okay, let's run this method, see what's happening. Producer tag. Producer just adds queue and consumer okay. So we can see here the work of the condition interface. Condition interfaces is full and is empty is conditional. So in this case, it waits for this condition to be reached. In this case, it just says that this condition is reached. In this case, is full condition is reached and is empty condition to be reached here. So we can just optimize, we can just improve the working with logs with condition instances. Okay, this video is over, so goodbye.